Good afternoon, everyone. Hope you're having a fantastic day. A couple of things we're going to talk about today. Writing equations for piecewise functions. Now, yesterday we figured out what a piecewise function is. We talked about how it's just a function that's built of different pieces to make one really big kind of Frankenstein looking graph. Everything just kind of stitched together. So, today we're going to learn figure out how to become the Frankenstein doctor. Dr. Frankenstein. Yes, yes, oh, the doctor. Oh, we're going to stitch things together and then create life. No, not really, but we are going to stitch together some equations. So, a couple of things here. When you're looking at this equation, the very first thing you want to do right out of the gate is identify how many pieces does this function have. So I'm going to look at all the different lines that go in here. So I've got a line right here. This is going to be 1. I've got a separate line right here. It's a different slope coming at a different angle, so it's going to be a second line. So I've got 1, 2. I've got a dot here, so that's going to be 3 pieces. And then another line here. That's 4 pieces of function. All right, 4 pieces of function. And then we're going to restrict those to all of their different little domains here. All right, so there's a couple of ways that you can do this. So I'm going to call this part 1. So let's figure out what part 1 is. Part 1, I'm going to do this over here to the side. I'm going to pick out, it's a line, so I'm just going to pick out 2 points and write the equation. So this point where it starts is -10, -3. And it stops at 0, 5. Okay, so I've got 2 points. Now I'm going to come down here and zoom in on this for a second. With those 2 points, if you'll remember way back to your algebra, you can come up with a slope, y2 minus y1, 5 minus -3, which is 5 plus 3, over x2 minus x1, 0 minus -10, which is 10. So 8 over 10, which is 4 over 5. So your slope is 4/5. And your y-intercept, we already found it. Your y-intercept is 5, or you could come up with point slope form. Either way you do it, it doesn't matter. It's going to come out to be the same thing. Just to kind of get you used to it, let's say that I didn't know what my y-intercept was. So I'm going to go to point slope, y minus y1, and I'll call this y1. -3 is equal to m times x minus x1 plus. So again, that's y minus y1 equals m times x minus x1. That's a formula you have to have memorized. And then distributed out, y plus 3 is 4/5 x plus, that would be 40 over 5. Get this out of the way. This would be 40 over 5, which is 8. And then subtract your 3. 4/5 x plus 5. So that means that this is the equation for the first section of my graph. Let me come back up here. Alright, so I'm going to make my big old bracket here. I have 4/5 x plus 5. And that is going to be for when x goes from where to where. Remember, x is how you measure it. So where does it start? Where does it stop? Well, it starts when x is -10. -10 x, and it does touch -10. It goes up to, and we'll say it touches 0 here. And then I come up with the next one here. Now you could have done that a little bit simpler if you would have just put it into y-intercept form, or excuse me, slope-intercept form. Slope is 4/5, your y-intercept is 5. But just in case you don't know what the y-intercept is going to be, I went ahead and gave it to you this way. That way you can do that in the future. So on this next one, since I know my y-intercept is 5, I'm just going to use that and count off your slope. You're going down 1, 2, 3, 4, 5, 6, and over 3. So 6 over 3 is a slope of -2. -2x, my y-intercept is still 5. plus 5. And that's going to be for going from 0 to 3. But notice since I touched 0 up here, I can't touch it down here. So I'm going to go from 0 to 3, and notice I do not touch 3 right here. So I want you to put a little note over to the side. You can only touch each x in one place. That means that, ooh, that doesn't look good, but in one place. That means if I touch 0 up here, I'm not going to touch it down here. Now, if I were to say I don't touch 0 here, but then I touch 0 here, it doesn't matter. Okay, so if you erase the touching 0 from here and you put it down here, it doesn't matter, just as long as it's only touching in one place. So I'm going to switch that around. I'm going to leave it up here and get rid of it in the bottom. Again, remember what I was saying, it doesn't matter as long as you're only touching it in one place. Okay, the third one here is just this dot. So that y value is 2. So your y is going to equal 2. And that is for when x is equal to 3. So when x is 3, it's just this point. When it's less than 3, it's over here. When it's bigger than 3, it's up here. But when it is 3, it's just 2. And then this one up here, this is a horizontal line. There's no slope there. So the value for this is just y equals 4. Y equals 4. And that's going to be from 3 to infinity. Now there's a couple of ways you can write it. Usually we write it with inequalities. So that's when x is greater than 3. You could say that either one of these, I'll go ahead and put this down, 3 like this. They mean the same thing, from 3 to infinity. Both of these mean the same thing. Either way you want to write it is perfectly fine by me. It's up to you. I'll leave that in your ever-capable hands. All right? Now, of course, they get a little bit more squirrely than this. So let's go to the back here. They get a little bit more interesting. They're not all just going to be lines and dots. So for number 2 here, I see 3 functions. I see, first off, I have a line. Second, I have a parabola. See this guy right here? Looks like a good little parabola. And third, I have a square root function, it looks like. Square roots. Now I know it's a square root because it keeps going forever because this arrowhead. Now even if it stopped right here, if I had a solid point, I'd still call it a square root. I would just have different things to do with it. I just stop my domain at a different spot. Okay, so I'm going to go ahead and come up with this. Remember, we always work from left to right. So left first, this guy. Now this is actually a good point to make right here. I don't know where this thing is going to hit the y-axis. I have no clue. I know I can kind of judge it sorta, and it looks like it might be right here, but I don't really know. It could be anything in between there. So I know roughly where it's about, but I can't just say, oh, it's going to be -8 or oh, it's going to be -9 and just guess all willy-nilly. So what I'm going to do is take the guesswork out of it. Here's one. We're going to call this part 1. I'm going to find 2 points like -10, 0. And their ending point is a good one, -2, -7. And I'm going to find the equation of the line there. So your slope is y2 minus y1, -7 minus 0 over x2 minus x1. -2 minus -10. Remember to watch your negatives here. We can't be playing games with this, acting like a bunch of freshmen in an Algebra 1 class messing up our negative signs now, can we? So add here, add here. That's going to be -7 over -2 plus 8, or excuse me, plus 10 is 8. This looks interesting. All right, and then y2 minus y1. I'm going to pick this first point here. Or excuse me, not y2, but y minus y1 equals m, negative 7/8, to x plus 10, x minus x1. Okay, so this is going to be y equals negative 7/8 x, and this is minus now 70 over 8. Just multiply that by 10, that's 70 over 8, or negative 7/8 x, see, 70 over 8. Both are divisible by 2, so that'd be 35 over 4. And that's where it stops. So interesting line here. It's not very pretty. Negative 7/8 x minus 35 over 4. Notice it's not fitting very well, or it's not a pretty line. There's no good, nice, neat y-intercept, but that's irrelevant. All right, so where does that happen? Where does that go from and to? Well, there's a couple of ways we can write it here. Here's where it stops. Stops at negative 2, and it's everywhere less than that, right? Listen to how I said that. Everywhere less than negative 2. Now the question is, do we actually touch negative 2? Well, yes, we do. So x is less than or equal to negative 2. Now remember that this is the same thing as saying negative infinity, to x to negative 2. Remember that those are saying the same thing, but this is just a shorter way to write it. Okay? Next, the parabola. Ooh. Okay, so I'm going to call this function number 2. I'm going to come down here. Let me kind of separate this thing. Function number 2. It's a parabola, right? And it looks like my vertex is going up 2, so I'm going up 2. It's upside down, so it's x-axis reflection. Means I'm going to have a negative in front of it. And let's see if we can find some good points. Let me zoom in on this. Let's find some good points. Well, here's our vertex. Go over 1. It looks like over 1 and down 2. And then this one here is down 1, 2, 3, 4, 5, 6, and over 2. So it looks like it's going to be multiplied by 2 as well vertically. Instead of down 1 over 1, we're going down 2 over 1, down 6 over 1. So it looks like we're going to be a vertical stretch by 2. So now that we have that, let's write the equation for it. It's a parabola, and it's going to be an x-axis reflection multiplied by 2, so that'll be negative 2x squared plus 2. I'm not going left or right, so it'll just be negative 2x squared plus 2. And where does that happen? Well, that goes from here at negative 1 to here at 2. So I'm going to say from negative 1, now notice it doesn't touch negative 1. So I'm going to say strictly less than x less than equal to, because it does touch right here, why not, 2. Okay, now that's the second equation. Now we can move on to the third. Now that third one there, he's kind of an interesting looking guy. We said earlier he's going to be a square root. So the first thing I need to do is position him, get him into the right spot. So it looks like this is my vertex for him, so I went, right 2 and down 6. So I'm going to call this part 3. 3 over here. I went right 2, down 6, and let's look at how big it is. So I'm going to zoom in here so you can get a good little glimpse at it. Here's my next good point. It looks like up 1 over 1, so it might not be changed in size at all. If that's the case, this should go up 1 and over 3 again. Let's see if it does. Up 1 over 1, 2, 3. Looks good. Up 1 over 1, 2, 3, 4, 5. Looks good. So I'm not changing in size, so all I have to do is go right 2 and down 6. So it's the square root of x minus 2 minus 6. And then we look at the domain. Where is it good for? Well, it starts at 2, but since we're touching 2 up here, I'm not going to touch 2 down here. So it starts at 2 and keeps going forever. So let's just say that x is bigger than 2. Now I know technically you're supposed to write it as x is bigger than 2. Who cares? It says the same thing, right? X is bigger. I don't care how you write it. X is bigger than 2. And that's a very short introduction to what a piecewise function is and how we graph them, or how we come up with equations for them. So again, the first thing I did, tell me how many equations we have. After you tell me how many equations we have, find an equation for each one, and then restrict its domain. So 3-step process there. All right. Tell me how many equations, find an equation for each one, restrict its domain. All right. Have a fantastic one.